Hello everyone. So yesterday we have done orbit of Bohr radius, right? Orbit of Bohr radius, and we found that Rn equal to n square h square E naught by pi m z e square, nah? And all these number are constant number, nah? And we got like this, right? Constant into n square. So this radius is directly proportional to n square. This n is integer, or it denotes the orbit, nah? In which orbit. If it is in first orbit, n equal to 1. Second orbit, n equal to 2, nah? So suppose this is nucleus, this is the first orbit, nah? So here n is equal to 1. If the electron is in first orbit, then we will use n equal to 1. If the electron is in second orbit, then we will use n equal to 2. So we will get the radius. First radius is r1, second radius is r2. So for first radius r1, 1 square. For second radius r2 is directly proportional to 2 square, like this. Okay, so now today we will find the total energy of these electrons, okay, in its orbit. So we will have the same diagram as yesterday. That is nucleus, again nucleus. I'm making a big, okay, so that you can see it. So inside nucleus there are z number of protons are there. So charge of proton is E, nah? So total charge will be Ze. So total charge in the nucleus is Ze, and electron is okay, and electron is orbiting in this radius. Okay, let's say its radius is Rn, and the velocity is Vn, and charge on electron is E. Since there is only one electron, so 1 E, nah? So 1 E is E. And then let's say its energy is En. So we have to find the energy, okay? And what we need energy on mass of the electron is, let's say, m, nah? So from Bohr first postulate. So what is the first postulate? From Bohr first postulate. Okay, you have to study what is first postulate and second postulate, okay? Better you just memorize these two postulates. So from Bohr first postulate, centripetal force is equal to electrostatic force of attraction, nah? So centripetal force formula is mv square by r na, mv square by r. So this is equal to electrostatic force na, so Coulomb force, right? F equal to 1 by 4 pi E naught Q1 Q2 by R square na, that force. So 1 by 4 pi E naught Q1 is Q1 Q2. So which one is Q1? Let's say this one is Q1 and this electron is Q2. Okay, so Q1 is Ze charge, Ze into Q2 is, what is the charge of electron? Electron charge is E na, by R square. So what is the distance? Rn na, Rn square. So here also it is Rn square. Okay, and the velocity is also Vn. Now you take this Rn, this Rn in the other side. So we will have mv square suffix n, okay, equal to 1 by 4 pi E naught Ze square. Now this Rn, so it will be in the upside na, so Rn square divided by, okay, this is not Rn square, this is only Rn, mv square by r na, mv square by r. So so Rn square. So here we can cut one Rn na, this Rn and this Rn we can cancel, right? So this one, and here we have 2 Rn na, so one will be cancelled. So we will have 1 by 4 pi E naught Ze square by Rn, mvn square. Okay, here see, this electron will have, the total energy of this electron will be, total energy of this electron will be kinetic, since this electron is moving, right? When it move, it will have kinetic energy. Okay, plus since there are two charges na, so due to this charge they will also have electrostatic potential energy, okay. So that means first we have to find kinetic energy and potential energy. Kinetic energy formula is what? Half mv square na. So here we have mv square, so I can easily make this into kinetic energy, right? If I divide by 2 na, then I will get kinetic energy na. So next step, dividing both sides by 2 na, dividing by 2, okay, both sides, in both sides. So mvn square divided by 2 equal to, now, so here it will be 1 by 2 into 4 pi E naught na, so 2 into 4 is 8 na, directly I will write 8, okay, 8 Ze square by Rn. So what is this? This part is kinetic energy na, kinetic energy of electron of mass m when it move with velocity Vn na. One by 8 pi E naught Ze square by Rn. So make this equation 1. So this is the kinetic energy. Next what we want, potential energy na. Okay, make this equation 1. Okay, according to your notes na, this is equation 1, this is equation 2. So next is potential energy. So what is the formula for electrostatic potential energy? So first unit na, first unit or second unit, or first unit second chapter na. So from there we have studied what is electrostatic potential energy is 1 by 4 pi E naught Q1 Q2 by R. So this is the formula for electrostatic potential energy. Okay, see the difference between electrostatic potential energy and electrostatic force is this R na. In electrostatic force we have R square. Okay, but for energy we have only 1 R, and it is minus. Okay, the whole thing is minus, this whole thing is minus. Okay, this is the formula. So this formula is coming from unit 1. Okay, so now here what is Q1? Q1 is ZE na. I will write, let Q1 is ZE and Q2 is E. Okay, so you can take any one. Okay, you can make Q1 equal to E or Q2 equal to ZE also. Okay, so therefore potential energy will be PE equal to, using this formula, minus 1 by 4 pi E naught. So Q1 is ZE and Q2 is E divided by Rn. So this is potential energy. So you can 4 pi E naught, Z into E is ZE square N. So this is the potential energy. Equation number 3 na. Therefore total energy will be total energy in n orbit. Okay, n orbit will be kinetic energy plus potential energy. So kinetic energy, so this is kinetic energy, right? So 1 by 8 pi E naught, 1 by 8 pi E naught ZE square by Rn plus potential energy is minus 1 by 4 pi E naught ZE square by Rn. Okay, pi E naught. Okay, this one and this one is same only, right? These two are same only na. So same we can take common, right? ZE square by pi E naught Rn is common na. So here the remaining will be 1 by 8 na. 1 by 8 plus into my plus minus is minus 1 by 4. So 1 by 8 minus 1 by 4 is how much? 1 by 8 minus 1 by 4. 1 by 8 minus 1 by 4. So LCM will be 8 only, I think. 8 na. So 1 by 8 is 1 minus 1 by 4 into 8. 4 1 is 4, 4 2 is 8, 2. So 1 minus 2 is minus, plus minus na. 2 minus 1 is 1. Minus 1 by 8. So you will have minus 1 by 8 ZE square by pi E naught Rn. So this is energy, okay, energy of electron in n orbit. So you can replace this Rn also, okay. Yesterday we found what is Rn now. Rn formula we have derived, right? If you remember that what is the Rn formula, then you can directly put, okay. Otherwise you have to derive it from second postulate, from Bohr second postulate. For Bohr second postulate, what is second postulate? Angular momentum is equal to integral multiply of n or h by 2 pi. So this is second postulate, nah? So what is angular momentum formula? Linear momentum is mv. So if it is angular, we have to put r, nah? mvr, and h by 2 pi. So here Vn equal to nh by 2 pi Vn mrn. So this one and this one will go to that side. That means it will come downside here. After that, we have to put this in equation 1. Okay, so equation 1, which is equation 1? Equation 2, equation 1. This is equation 1, mvn. So here we will put v, just like yesterday only I am doing. V score is there, right? So that means we have to score all these things. So if you score, then n score, h score, 2 score is what? 4, pi score is pi score, m score is m score, rn score. So this will be equal to equation 1 by 4 pi E naught ZE score by Rn. So 1 by 4 pi E naught ZE score by Rn. 1 by 4 pi E naught ZE score by Rn. Okay. So now cut whatever you can cut. Okay, so pi 1 Rn will cancel. H pi and then 1m cancel, and 1 pi cancel, 4 cancel. So we have n score h score by pi m Rn equal to okay. What is Vn? Okay, where is Vn and h by 2 pi. Okay. Okay, so we have ZE score E naught. So we are going to replace Rn. here this Rn we have to replace, right? So from here we can find out what is Rn. So this Rn, so this Rn I will take this side and all this in this side. Okay, so this will be equal to Rn. Since it is in downside, so when it goes to that side it will come in the upside, nah? So n square, h square. Now E naught, if it transfer to other side, then it will go in the upside, right? E naught and pi m Ze will come downside, nah? Ze square. So this is Rn, n square h square. So now put this Rn in, where is the energy? Here. So minus 1 by 8 Ze square. Therefore E equal to minus 1 by 8 Ze square minus 1 by 8 minus 1 by Z square pi E naught, pi E naught. Okay, here we don't have square, nah? So directly we can put, okay, Rn is in downside, so n square h square E naught divided by pi m Z square. Now so this downside one will come in this side, right? Minus 1 by 8 Ze square pi m Ze square divided by pi E naught n square h square E naught. So now cut whatever you can cut. I can cut this pi and this pi will cancel, n square, and we can cut anything. Minus 1 by 8 Z square. There are two Z, nah? Z square. E will become 4, E power is 4 m divided by 8 is already written. Here also we have 2 E naught n square h square. So E. Okay, now here Z is a constant for an atom, nah? For hydrogen Z is constant, right? 1, nah? And E charge is also constant. It is a number, fixed number, so it is also a constant. E naught is also a constant. H is Planck constant. So we have like this, constant divided by n square. The only variable is this n square. So E is energy En. Okay, write En because it is in n orbit. So energy of electron is inversely proportional to n square. Okay, n is number of orbit, okay, in which orbit the electron is there. Okay, it indicates the position of that orbit. So this is the energy, total energy of electron.